So I'm really thrilled to be joined by a bunch of different fantastic analysts here at Tibco. Jagrata Minardi is going to kick things off today, and he's a solutions consultant at Tibco, and he's specialized in the financial services area. And Jagrata is going to take us through some of those concepts that I mentioned around doing custom expressions, showing how we can edit those, create a data function, and then the process of doing that inside of Spotfire and inside of RStudio. So, Steve, are you able to give the ball to Jagrata to start off the demonstrations today?
Yes, Jagrata, you are now the presenter. Please share your screen.
Thanks, Steve. Thank you, Michael. Can you see my screen okay?
Yep.
Okay. So I'm going to show 4 examples today, all of which involve the Tibco Enterprise Runtime for R, or TARE, as Michael described. In the first one, we're going to go to the introduction screen here in the samples area. And one of the examples is from advanced analytics, Spotfire analysis. And what we're going to do in all of these is show at what point in normal use of Spotfire you might step over the line and want to reach for something that involves TARE. In this first example, which ships with Spotfire, we have a combination of instruction and also special examples. And the idea is that you can be guided by the instruction through forecasting or correlation, comparison of mean ranks, etc. And then you can take it apart and perhaps adapt it for yourself. We'll focus on this example here, a clustering example, in which we're looking at data from the World Bank and seeing scatter plots of life expectancy at birth versus gross national income per capita. Every observation is a country, and this particular chart on the top is focusing on 2007. We can move the slider around and see a snapshot of a different year and compare 2 years in the top-bottom comparison that we see. Now, if you've used Spotfire before, you're probably familiar with the idea of adding a calculated column. There's this expression language inside of Spotfire, which reminds you quite a bit of Excel, which allows you to type an expression to create a column that's either on the data set or it's on one dimension of an analysis of a visualization, such as the color by attributes. Inside of the statistics functions area, there's a few functions that have the word TARE in their name. And these will allow you to create a column of the different data type indicated using an expression that we'll call the TARE engine that's embedded in Spotfire. Now, this could be very nice because it extends the flexibility of the expression language, because the first inputs of the function here is going to be an expression in the R language, which would be executed by TARE. And how might you use that? One example, if we look at the expression underneath the color by attribute of the scatter plot, we see that it generates an integer column using the expression that's highlighted here. First, we set a random seed, then we call the k-means function, and then we capture the cluster identifiers off of the output of that function. The way that this works, I'll say briefly, is that the first argument for the TARE integer function is that expression. Following arguments, here there are 2, provide the values for the named inputs in that expression. The expression needs to create something called output, and that'll be automatically coursed by Spotfire into a proper column. In the case of this custom expression, the column doesn't persist beyond the scatter plots. The clusters document property is automatically substituted before the expression is evaluated. And I see that I'm sending in 2 columns, common log of the x-axis expression and then the y-axis expression. So we're using the 2 columns that are being rendered. And so we move the cluster setting to see fewer clusters or to see more clusters. We'll see the graph update. Both of them will update accordingly. And by the way, if you're noticing that it seems a little funny to cluster these points differently, remember that we were looking at the logarithm of the x-axis variable. So if we were to impose a log scale you can see a more rational view of the clustering that was done under the hood. Now, it's really nice to be able to use these tear functions, and as Ian is going to show us, you can even add to the list of tear functions. This tear inline expression is limited, though, because it is going to allow us only to create one column or one attribute, one dimension of outputs. Now, we'll see a second example now in which we go beyond that. I'm going to talk about a couple of ways in which you might come to the line. In this example, we've got a simple data set with a string variable called group.1 and two numeric variables called x1 and x2. And so imagine that you want to create a second data table in Spotfire based on a selection that you make from this first one, in which we look at groups of observations, groups of rows, within each unique value of group.1, and then x1 and x2 will be summarized by, let's say, median. In other words, you want to create an aggregation table. Again, if you've been using Spotfire, you're probably very familiar with the fact that I can add data tables to an analysis, and they can be based on an existing data table inside of the analysis. And when I do that, I can impose transformations. Well, you don't see aggregation in the list here, and so that's what we want to talk about in this example. That's how we've stepped over the line. And to address it, we're going to use what we call a data function, which is simply an embedded script inside of Spotfire. When you work with data functions in Spotfire, there's two steps. And the first step, which will be done once and perhaps shared by many different Spotfire authors, the person is going to register or publish the data function. Let's create one on the fly here. I'll call it aggregate, and it will be an R script that will execute with Tibco's runtime. So as Michael mentioned, Tibco Enterprise Runtime for R, or TARE, is meant to execute your R code faster than R. We can add a description. We can include packages that need to be loaded. You might want to disallow caching if your routine invokes a random procedure that you want to use to give a different answer every time. And then there are three tabs to fill out. The script, first of all, which we're going to freehand here, is going to use the aggregate function in R. I'm assuming for the moment that I have a variable called a data frame called X. We'll get back to that. And it's going to represent our data table in Spotfire, which, as you remember, had three columns. The first argument, aggregate, is meant to be the columns that are going to be aggregated. So for us, that's going to be x1 and x2. Then the by argument is meant to be a list which is representing the vectors that we group by. In this case, it's simply the single vector, the group one column inside of my analysis. And then the last argument, fun, is either an anonymous or inline defined function, or one which is available through the base or other packages. I'll assign this to an object called Y, and then we've created our script. Now, if you are assuming that something exists called X, you must nominate that as an input parameter. So I'll do that, and there are three types of parameters: a vector of length 1, a vector, and a data frame in terms of R. And we'll see shortly how that translates when we map it into Spotfire. I am interested in either numeric data types or a string. The grouping variable will be a string. I can have any number and combination of variables. So you see input parameters. So you see that these data functions are immediately more flexible than inline tear expressions or published tear expressions. Similarly, for output parameters, I created something called Y. And anything that we create in the script that we want to push forward to Spotfire, we need to designate as an output parameter. It's when it's a type table, and again, I can have any number and combination of output parameters between the three different types. This is great. I could save it to the Spotfire library for reuse, which is a critical deployment functionality. Or if I'm in development mode, I can simply embed it in my analysis and run with things. I'm going to refresh this automatically, and for my table inputs, I'm going to select columns from my original from my original data table. See if I can get that. And now we've mapped our inputs and outputs to things that are inside of the Spotfire analysis columns, in this case, in the new data table. When closing this, I'm prompted to save the data function in the library. We can always do that later on by clicking Save to Library. And so when I did this, it automatically ran. Let's add another table visualization to this page and move to the aggregated data table and see that if I make a selection now, it will update the aggregation, which appears. And so that's, in short, the two steps that you need to do to embed a script inside of Spotfire. When you do this, you're typing inside this text area in the dialog, in the Edit Scripts dialog, and that's not the ideal place to develop a script. So we're going to talk about that in the two examples that follow. I'll just mention here that as you do this process, you invariably will find things that you want to change. For example, if we unmark these rows, I raise an error inside of TARE, which says, hey, there were no rows to aggregate. And so you do a head flap and you say, yes, of course, I should have added something to trap for that. So I'll briefly add a couple of lines to indicate how you might evolve the script. If there are rows for X, well, in that case, you might do this aggregation. And if there are no rows in X, well, then you might just want to return X. It has the right columns, and it has no rows. That would be the expected answer if you're aggregating nothing. And so we see now if we make a selection and then we unmark the rows, we get an empty data table on Spotfire. Let's move to another example, which is more built out, to raise another point where you cross the line. If you've used Spotfire before, you know you can embed calculated values inside of text areas that dynamically change on filtering or selecting. And you probably know that there are standard, covariance calculations and standard deviation calculations in the expression language. So you could surely report the correlation between two columns of a data table. In this data table, I have a number of companies that are domiciled in different countries, whose stock trades in different currencies, who are in different sectors of the overall market. And for each company, we have a number of different metrics that give a snapshot of the stock performance at a certain point in time. It would be easy to choose two columns here and generate a correlation in Spotfire, but what if you want to use several columns and present a correlation matrix? Or, as in this case, what if you wanted to do row correlations in which you nominate a few columns that would form a kind of profile for each company in the list, and then perhaps you would want to take those 4 tuples in this case and use them to correlate rows that are selected in the table. Well, that's another point in which you go beyond what's reasonable to do with the expression language and you move into the scripting world. Let's take a look at this example. Again, the person putting together this analysis really will only have to go to the Edit Parameters dialog. That person is not going to have to look at the script, know what language it was written in. We're happy to do that here because we want to go deeper down, but the division of labor is something that we're very proud of that's very, very useful in the field to extend the reach of these kinds of analytics. In this example, we have a more interesting way of mapping the parameters. What we want to do is send this identifier plus the profiling numeric columns over to the script that will run. These can be named with descriptive names, and there's a flexibility of handling the inputs, as we see. In this case, instead of looking at columns, just cherry-picking columns, I've written an expression here. Actually, the expression was written with the help of the expression builder. And if we were to look at this, it looks a little complex, but in fact, it can be created with point and click. I mean, if I want to insert the name column as my inputs, we can just do that. And when the dollar sign with the squiggly braces is automatically generated when I insert a property through insert properties. And the map function, which resolves to the sum comma separated list here, is automatically generated when I choose from the property list in the middle here, columns to correlate, which is the multiple selection that's happening underneath this list box. You click it automatically, generates the mapping substitution function, and as you can start to see in the resulting expression, it indeed resolves to the set of choices that are made in the background there. And so with point and click, you can do that mapping in Spotfire. By doing that, you can also give a high degree of interactivity to what follows. The last thing I'd like to say in this example is that you can, in creating these scripts, you have the option of bringing things in from a file. We talked about the fact that the person making this analysis doesn't have to interact with the script, see it at all. Somebody at one point or another needs to register or publish the data function. They can do it freehand, as we did in our first example, or Spotfire allows you to represent the details of a data function using, oh, that's a horrible, yeah, using a file. So I can see that's not going to work in the WebEx. I'm going to skip that part. If I can cancel that. Now, we'll show how to create these files. They will fill out all three tabs here, plus the checkbox and the description and the name and the type of data function. So if you have lots of inputs and outputs, it's a great option to be able to just import the script file definition from Spotfire. Let's go to the last example and talk about another way in which you might cross the line, as it were. In this example, I'm embedding a heat map that was generated from a simple parameter specification. So this is not coming from a data table, and that's why we're not using a native Spotfire heat map. But rather, this is being generated by a data function. R is being used to generate this heat map. It has a random generation to it, so we see it change as we refresh it or change the dimensions of it. And what we'd like to do here is look a little bit deeper into the workflow of how it's created. When we start with the data function properties and look at the script, it's a short script, but we see that it loads the R in our library. This is part of the base TARE distribution, which allows you to call out to open source R in part of your TARE function, the TARE script. And in this example, because we didn't build graphical routines into TARE, because it's so closely linked to Spotfire, we allow you to call out to graphing functions in R in a convenient way. Now, again, this is not the best environment to develop a script, so I'd like to talk about how we would use RStudio in this case, in all of our data function cases, to develop interactively the script before publishing it. As RStudio is a very popular IDE for R. We support it with TARE as well. This file here is my harness for developing a data function. In comments at the top, we see a lot of metadata information that you would type into the dialog. Later, I'll show how that can get into the dialog without having to type. In the next section, we interactively set the two input parameters that the script expects. And we use this section to iteratively work with the script, make sure that it gives valid answers and that it's corner case and is robust against unexpected inputs. We initialize something called message, MSG. We load the R in our library. We set the R path to its where the R executable exists on my machine. And then we generate a matrix of random normal variates of square dimension n. I'll run to here in RStudio using Alt-Control-V and dissect this next line a little bit. R graph, if I hit F1, you see it's a function that's in the R and R package. And as it says, it allows you to generate graphics by passing an expression to R. In the passing, elements of your current care environment are seamlessly managed and passed to an R environment. And we see that we're using the image function to generate a heat map. The variable Z is going to be our normal variates, which are kind of damped down by the row and column indexes in the matrix we formed. Following this, there are optional arguments, and in the display argument, if false, causes RGraph to return raw bytes. This is critical for our example, which would represent the contents of a PNG file that rendered the image. These are sent back to Spotfire and is rendered in a label control, which makes things show up. Now, that's great. I'm wrapping everything in try here so that if we do encounter an error, we have the opportunity to check for it and handle it. And so we could see, for example, if we change the R path to something that was incorrect, we would get a traceback inside of Spotfire. Finally, if display is set to true, as it is in this commented line, running it will allow you to view the graph inside of RStudio. Let's make sure that we run 28 and 29 first, and then we'll run the rgraph command with display equal true. And inside of RStudio, we'll see the heat map show up. And so we can use this for the full development of the script. I'll mention before going back to Spotfire that if you want to create these so-called SFD files that represent the data function for import into the register data functions dialog, you can do it from Spotfire. I have a small package that supports this activity. It contains a function which goes through all of the data functions I use in my demonstration, and it calls several different routines that are part of the Spotfire utils library. Oops, excuse me. I'll bring up this just to put a point on that. Inside of the Spotfire utils library is a number of routines that allow you to create these representations, file representations of data functions. And when I run this routine, it goes through all of the different data functions in my list, and it regenerates these SFD representations of them. Back in Spotfire, I'll close things out. I'll finish up by just mentioning that this text area on the right exposes as label controls the message and the image that is sent back from the data function. And if we were to change this path so that it's no longer correct, then we would see a traceback show up. That's the message, and it's just a placeholder for the image. Resetting it, of course, gets us back in shape. So that was happened to be very useful in developing the script and hooking it up with Spotfire. So that's the 4 examples I wish to show today. We tried to show you several instances in which you cross the line and move into a situation where you'd like to have care scripting. We tried to present the vision of the gamut of use of how care data functions naturally extend some of the other point-and-click inbuilt functionality in Spotfire. And what we'll see next from Ian is a number of very cool applications of this to geospatial work.
Yeah, what Joe Grata just showed you was he walked you through typing on the fly to do clustering in an inline expression. Showed you some data functions for picking off rows and particular columns to create a correlation matrix, and showed how that was constructed in a data function. And it showed you the development environment for putting an R graph inside of a Spotfire analysis. The graph itself is not interactive, but the controls are in Spotfire that allow you to generate different versions of the graph based on different data in Spotfire. That is all interactive. So you can extend your graphics palette with anything in R, in this way. Jagrada also showed you how to create SFD files that you can share data functions and bring them into the library, importing and exporting SFD files. He showed you how to create those in Spotfire, but also how to create them in R. This allows us to share things, and we're going to share some SFD files with you today. You'll be able to import right into your Spotfire library and use them in your Spotfire analyses.